Hello grade 10s. Today we're going to cover a very quick and easy concept, and that is of special angles in trigonometry. You're going to see that there are unique angles that we work with often, and the instruction in a test is usually to simplify or evaluate without the use of a calculator. So you need to know your special angles so that you can substitute what they equal to without using a calculator. Now I want you to imagine angles on the Cartesian plane. Imagine you have a ray of an angle which is 2 units in length. The special angles will always have a ray that has 2 units in length. The first special angle is 30 degrees. The next one is 45 degrees. The next one is 60 degrees. And then the two that I haven't yet mentioned are 0 degrees and 90 degrees. So this line over here represents 0 degrees, and this one up here, I haven't put the symbol in, but you can see that a vertical line along the y-axis will obviously make 90 degrees between the y-axis and the x-axis. So what you need to do, oopsie, my animation's in the wrong order, excuse that too for now. I want you to imagine x values going down, starting at 0. Obviously, if you are along a vertical line, if this coordinate right here, the x value would be 0. Then if we hop to the next one, the x value of this coordinate is going to be 1. This is why these angles are so special. The x value of this coordinate would be 2. The x value of this coordinate would be 3, and the x value of this end of this line would be 4. Then the same happens with the y values. If you are chilling here on the x-axis, the y value of this coordinate would be, up here, I'm starting at the top again. If you're up here on this high point of this vertical line, the x value would be 0 and the y value would be 4. And then we go down. Here the y value is 3, 2, 1, and 0. But that's just a way to remember it. Actually, those coordinates are all square rooted. So the next slide is going to show you the real coordinates of those special angles. I square rooted and simplified each of my answers. Remember, there was a 4 as my y coordinate in the previous slide. Square root of 4 gave me 2. Square root of 0 is just a 0. Square root of 1 is just a 1. And square root of 3 we cannot simplify, so we leave it in this what we call surd form. And here we have all sorts of coordinates that we can apply to SOHCAHTOA, or shade your rear, cos x-rays, tan your exterior. We have all sorts of special angles with their relevant x and y coordinates, and don't forget that the r in every single situation is going to be 2. So now I can ask you, for example, what is tan of 30 degrees? And you can go, okay, let me go to the 30-degree line. Tan is y over x. Y in this case is 1. X is root 3. So tan of 30 degrees is 1 over root 3. Let's give another example. What is sine of 60 degrees? Let's go to the 60-degree line. The coordinate is 1 and root 3. The r is 2. Sine is y over r. So we're going to have root 3 over 2. And that is that. So this is the diagram you can use if you don't use a calculator when determining the value of special angles in trig functions. I've just repeated that little diagram, and I've given you a table that gives you the special angles and their corresponding values. Now you're going to notice this I obtained from the calculator. Have a look here. In the previous slide I said tan 30 degrees is this line here, and tan is y over x. So 1 over root 3. Yet here we've got √3/3. Now, I don't want you to worry about that. This is perfectly fine. You're allowed to use this one. The calculator does something called rationalizing the denominator. Now, that's a little trick. You're only going to learn in grade 11, so don't worry about it for now. Tan 30 is definitely one that differs from the rest, but all the others are perfectly fine, and you should be able to use this diagram to work out your special angles without a calculator. So now we're going to jump into an example. Evaluate without the use of a calculator this scary looking thing. All you need to do is break it down into the three components. There's a sine, there's a tan, and there's a cosine. So I want to give you a sneaky tip, and this is very naughty of me to tell you this, but if you break it down in those three components, sine, tangent, and cosine, you can use your calculator, but don't go and put this entire thing into your calculator. That's when you're going to get no marks. But if this diagram with the R's and the X's and the Y's and the X-axis and the Y-axis, that's a little bit too much for your brain to memorize right now. If you're feeling like, this is a bit exhausting, I'm going to give you permission to use your calculator, but in what I like to call baby steps. So I'm going to put sine 45 into my calculator and jot down its answer. And you'll get √2/2. If you use the diagram, you'd get the same thing. Then I'm going to do the cosine, just because I'm leaving tan for last. Cos 45 is x/r. Pop cos 45 into your calculator, and you'll get √2/2 again. Keep your answer to one side. Then let's do tan squared of 60. So tan squared 60 is just shade your rear because extra is tan your exterior, y/x. But because of this square, remember this squared is in a funny spot. It's exactly the same as saying tan 60, all in brackets, squared. Exactly the same. Y/x times y/x. If you pop tan 60 into your calculator, you'll get √3. Because we're squaring it, we times by √3 again, and then we say that equals 3, and keep it on the side. Now watch how I substitute each of these separate answers. √2/2, √2/2 times by 3. Substitute each of those separate answers into a fraction like that, and then you can cancel out and get your final answer. So basically, you're allowed to use your calculator, but in baby steps. Don't go straight from this first line here all the way to equals 3. And then you'll be A-okay. Do your homework, reach out for your teacher, and good luck for your test tomorrow.